All right, today we're going to take a look at complex fractions. On page 17, it says, Dana is skating laps to train for a speed skating competition. She can take one lap in 40 seconds. It says, write a ratio in simplest form comparing Dana's time to her number of laps. And it's important that they want you to compare the time to her number of laps here, because typically we're going to put time on the bottom and the distance on top, like miles per hour. They want you to do it the opposite way, which is going to seem a little weird to us. So her 40 seconds they want to put on top, and they want you to put the one lap on the bottom. You will recall that this is called a unit rate. And this unit rate represents Dana's speed skating in seconds per lap. Well, suppose Dana skates for 20 seconds. How many laps will she skate? Well, 20 seconds is half of 40 seconds. So she's only going to skate 1/2 of a lap. She's not going to get a whole lap in half the time. It says, write the ratio of Dana's time from exercise 2 to her number of laps. Well, that's going to look like this. It's going to be 20 seconds on top, a larger bar, and then 1/2 on the bottom. That looks really strange, right? We don't write fractions that way, but yet we can. And this is called a complex fraction. This is, how could you simplify the ratio you wrote in exercise 3? Well, this is not a unit rate, right? So if I wanted to change it to a unit rate, I would take the top number and divide it by the bottom number, just like we were doing in lesson 1. Well, that's what we're going to do here. If you can recall from chapter 4, when you take a whole number and then divide it by a fraction, you would put the whole number over 1, then you would keep, change, division to multiplication, and then flip 1 over 2 to 2 over 1, which is called its reciprocal. And actually what we end up with is 20 times 2, which is 40. So we end up with 40 over 1, 40 seconds to 1 lap. The reason they showed you this particular problem at the beginning of this chapter is to show you that when we simplify a complex fraction like 20 over 1/2, you're actually turning it into its unit rate. It says fractions like 20 over 1/2 are called complex fractions. So there's that vocabulary word that you defined last week. It's a complex fraction because either the numerator, the denominator, or both are a fraction. Complex fractions can be simplified when both numerator and denominator are integers. So we need to turn them into whole positives or whole negatives. It says simplify 1/4 divided by 2. So this is example 1 on page 18. It says recall that a fraction can also be written as a division problem. So that's what we're going to do. First, you will write the original problem. Notice the different sizes of the bars. This bar is smaller, and this bar is bigger. The big bar is where the division symbol is going to be used. So when I write this, 1/4 will come first, the division sign for the big bar, and then the 2 comes second. And remember, we're going to put that over 1 because it is a whole number. Then we are going to keep 1/4, change division to multiplication, and then flip 2 over 1 to 1/2. We multiply straight across the top, you get 1. Straight across the bottom, you get 8. Now the top number is a 1, the bottom number is an 8. This is no longer a complex fraction, so it is simplified as 1/8. Look at number 2. It says simplify 1 over 1/2. This time, the big bar is here, and there's a little bar here. So 1 over 1/2. So we would take 1, use the division sign for the big bar, and then 1/2. Well, we would put 1 as 1 over 1. We would keep 1 over 1, change division to multiplication, and then flip 1/2 over so that it is 2 over 1. So basically we end up with 1 times 2, or just 2 over 1, or even 2 as our whole number answer. So as long as you do all right with dividing fractions and remember to keep, change, flip, these are not as complex as they look. So, and do the problems at the bottom of page 18, letters A, B, C, and D. Let's take a look at example 3. Now we're going to look at this complex fraction idea as forming a unit rate. It says Josiah can jog 1 1/3 miles in 1/4 hours. So there's that miles per hour idea of forming a rate and turning it into a unit rate. It says find his average speed in miles per hour. So we're going to start off with 1 1/3 miles on top, big bar, and then 1/4 hours on the bottom. So just like we were doing in lesson 1, we're going to take the information they gave us, the situation they gave us, and write it as a rate. 1 1/3 miles on top, 1/4 hours on the bottom. Now we're going to turn that into a unit rate by dividing the top by the bottom. So 1 1/3 divided by 1/4. We need to turn that mixed number into an improper fraction. Remember, you cannot just divide a mixed number. You got to make it an improper fraction. So we're going to multiply 3 times 1, get 3, and then add 1 to it. That makes it 4 over 3, and then divided by 1/4. Notice I'm not going to cross simplify here because it's still a division problem. I'm going to keep, change, and then flip 1/4 to 4 over 1. And now I'm going to look, can I cross simplify? Well, 3 and 4 won't simplify. 4 and 1 will, but it will only just still be 4. So we're going to multiply straight across the top, get 16, straight across the bottom, and get 3. 16/3 is an improper fraction, so we're going to change it into a mixed number. Keeping in mind, we have actually now found a unit rate. So whatever our answer is, it's going to be in miles per hour. So 16 divided by 3. 3 goes into 16 5 times. 5 times 3 is 15, so I have 1 left over. I put that on top. I put my 3 back on the bottom, and it's 5 1/3 miles per hour. Look at example 4. It says, Tia's painting her house. She paints 34.5 square feet in 3/4 of an hour. And it says, at this rate, how many square feet can she paint in an hour? So we're looking for feet per hour. So when we do this problem, we're going to put 34.5 feet squared on top, and we're going to put 3/4 hours on the bottom. So we write our rate in a fraction form. Then we're going to turn it into a division problem, dividing the bottom number into the top number to turn it into a unit rate. Again, we can't divide mixed numbers, so we have to turn it into an improper fraction by multiplying 34 times 2, which gives you 68, and then we're going to add the 1 in, that gives you 69, over 2, because we just bring the same denominator over, that's still being divided by 3/4. Now we're going to keep, change, flip. So we're flipping the divisor to its reciprocal, and then we're going to ask ourselves, can I simplify this multiplication problem to give me smaller numbers? 2 divides into 4 evenly, so the 2 becomes a 1, and the 4 becomes a 2. And I know 3 goes into 6 and 3 goes into 9, so 3 will go into 69. So 3 is going to become a 1, 3 is going to go into 6 2 times, and 3 is going to go into 9 3 times. So 3 divides into 69 23 times. Because I have 1s on the bottom here, then all I have to do is multiply straight across the top, and I will get a whole number answer. 23 times 2 is 46. And since it would be 46 over 1, I can just leave it as 46. And it's 46 feet squared per hour. So /hour. 46 square feet per hour. That brings us up to the letter problems on the bottom of page 19. On page 20, number 5, it says, on Javier's soccer team, about 33 1/3% of the players have scored a goal. Write 33 1/3% as a fraction in simplest form. Well, some of you are thinking, well, just take that 33 1/3 and turn it into a improper fraction. But if you recall, 33 1/3%, the word percent means divide by 100. It means divide by 100. It's literally per 100. The word cent means 100. So we would actually write 33 1/3 over 100 if we were writing it as a fraction. So again, that is a complex fraction. And the way we change complex fractions into their simplest form or into unit rates is we would take 33 1/3 and divide it by 100. We're going to change 33 1/3 into an improper fraction by multiplying 3 times 33, getting 99, and adding that top number 1 into it. And so you get 100 over 3. Then you are going to divide that by 100 over 1. You will keep 100 over 3. Change 100 or change division to multiplication and flip the 100 over 1 to 1 over 100. The nice thing here is that the 100s being diagonally from each other now will cross off, and I'm just left with 1/3. So 33 1/3% is a fraction of 1/3 in simplest form. And that makes sense because 33 1/3% plus 33 1/3% plus 33 1/3% would be 99 3/3, which is, when I divide 3 into 3, I get 1, which I would carry, would equal 100. So 1/3 of 100, 33 1/3. So 33 1/3% is 1/3.